In problem number 2, we want to find what points on the graph of y equals 4 minus x squared are closest to the point 0, 2. So let me just sketch a picture of this so you can see what's happening. Let's get a pencil and sketch a picture. It's going to be a lot more helpful. All right, so we know that this is a parabola. It's shifted up 4 and it's going down. So this is what it looks like. And we want to know what point on that parabola is closest to the point 0, 2. Okay. Now, just from eyeballing it, I don't know, it kind of looks like it might be like here and here, okay, that there's going to be 2 points, but that's what we're trying to do, is minimize that distance. So our primary equation, the thing that we are trying to minimize is distance. So we want to use the distance formula. So our distance formula is x minus, now our x coordinate, we're minimizing the distance from that point, and then y minus 2. So that's our primary equation. That has 2 separate variables in it, which we don't want. So our secondary equation is right here. We're going to plug that in for y. So we are looking for, now x minus 0 squared is just going to be x squared. And then I'm going to plug that secondary equation in for y. And we'll keep going here. So I want to simplify this, make it look a little nicer. So this is 4 minus 2, so 2 minus x squared. Okay. And then I want to go ahead and FOIL this out and combine my like terms. So when I do that, I end up with x to the 4th, and then I get minus 2x squared minus 2x squared, so minus 4x squared plus 1, so minus 3x squared plus 4. So I know I didn't show all of the work on that, but that's what this will look like. So now I've got my primary equation, and it's all in one variable. So I want to take the derivative of this and set it equal to 0. Now, we're going to take a little shortcut here. We're going to cheat just a little bit. We are trying to minimize the square root of this thing. As long as we minimize the part underneath the square root, that's also going to minimize if we take the square root of it. So for this problem, we can just ignore the square root and just focus on this part. And that'll make things a lot easier for us. So let's take the derivative of that. So the derivative is going to be 4x cubed minus 6x. We're going to set that equal to 0. And I'm going to go ahead and factor out a 2x. So that gives me x squared minus 3. How about a 2x squared? There we go. And then when I set those both equal to 0, I get x equals 0, or x equals the square root of 3/2, or the negative square root of 3/2. Now, notice I have 3 different points, okay? Here, here, and here that are all potentials. I want to make sure that I have a minimum, okay? So what we're going to do is put it on the number line, and we're going to actually check. It's like the first derivative test. We're going to plug it in and see what happens. So square root of negative 3/2, 0, and the square root of 3/2. Okay, so I'm going to come back to this thing. I'm going to pick numbers in the different regions and check and see what's happening. So when I pick something down here like -2, I end up with a negative value. If I pick something like -1, I get a positive value, and then negative and positive. So notice from here, we're going from negative to positive. So this is a relative minimum, which is what we wanted. Now 0, it's going from positive to negative. So this is actually a relative maximum, so we don't want that one. And then this is another relative minimum, okay? So if you get more than one answer, you're going to need to put it on a number line and actually check it and find out what they are. So let's go back to the original question. Which points on the graph are closest? We have the x coordinates. It is the square root of 3/2 and the negative square root of 3/2. And to find your y value, just go back to that secondary equation and plug in. And I think you get 5/2 when you do that for both of those. Okay. So you'll see these problems in your homework. Make sure whenever it's minimizing a distance, you are using the distance formula.